we have computed where we can insert the expression, and that is known as can be available. What we will now compute is the attribute will be available, and that starts with can be available, and then we may decide to do it to insert the expression later. Okay, we want to avoid reserving a register resource during a longer time. So if we have this example, it's a bad idea to insert a plus b here, since we have to keep it in a register all the time until we come here. This a plus b will be optimized away in this example. Okay, so what we need to do is to check if the expression can be available, and then if there is an operand which has a real use, because then we have to insert it. So here we can say that these have no real use, and here as well, and therefore we can do it later. But when we come to this one, that operand has real use, so we must insert the expression for this operand. That means at the end of this basic block. Okay, and then we need to tell phi functions with operands which are defined by this phi function. So that is done when we call reset later. We call reset later for f, and the parameter then changes name to g. Okay, so we set later to false for this one, since it has an operand with real use, and then we check each phi function with an operand defined by g, and if that phi function still thinks it can postpone inserting the expression, I mean not inserting the expression, then we tell it that it has to insert the expression. That means reset should be false for this one as well. So we reset later, and it will continue. So now we are almost done, and we are in the first of the two finalize steps. We will not look at the finalize 2 because it's quite tedious, and is best looked at the moment you implement PRE. Okay, but finalize 1 is important to understand, and is quite interesting. So what we have an expression, and we have the different versions of h for this expression, and we call this different redundancy classes of the expression. Okay, so say there are 4 different versions of h, then we create an array which is called availdef. I mean, this is this one, and what this will contain is a pointer to an occurrence which defines that version of h. Okay, so what we do is a pre-order traversal of the dominator tree, and we check this, we inspect the occurrences and in this order, and we check which version of h it is related to. So if this is a phi occurrence, then we check if it will be available. If that is true, then we set the availdef to this occurrence. So say we have we can say we have a phi function here, and we say that this is can be available. So then we simply set a pointer to this instruction, to this occurrence. Okay, if it is not will be available and is a phi function, we just ignore it. On the other hand, if this is a real occurrence, take this one, and then if eval_def is bottom for this version of H, we can say this is H1, then we set it to this occurrence. Okay, and the other alternative is that there is already something with this version, but it does not dominate the current occurrence, and that happens here. We can say this one is also H1, and when we come here eventually, we will get this pointer, and then we have to check that this one dominates that one, otherwise we cannot benefit from it. Okay. So if we can optimize away the current occurrence, real occurrence, then we say reload is false, and if we cannot optimize away the current occurrence, then we say reload is false, which means we will evaluate it, and then we say this is the occurrence which defines this version of H. Otherwise, we say that this occurrence should load the value from H instead of computing it, and we take as the definition where this occurrence gets its value from the pointer from the occurrence which defines this version of H. Okay, and then the third case is the phi operand. And then for a phi operand, it is, okay, say we have a phi operand, we have a phi function here and a phi operand here. So here is the occurrence, and here is the phi function f, which is where that one is an operand. Okay, then the question is, should we insert the expression here a plus b? Well, the question is answered by if this one first the phi function will be available. If it's not, we ignore it, and then if it satisfies insert, that means it's a bottom operand. Otherwise, it will be, get the value either from a real or from a phi occurrence, according to the pointer in the array. Okay, that's SSA pre. What is needed then after this is to change the big phi functions to normal phi functions, and make sure that the some additional pointers to get this work are updated as well.